we will study Doppler Effect. What is Doppler Effect? We will see, or we will observe, the effect of moving body or moving source of sound on the frequency of the waves you will hear. As we said, as the source of sound is moving, you will hear different sounds. As an example of fire truck, I'll show you now. This is the center of sound of source, like this one. You can see the siren up there and the dog. Forget about the dog, as I told you before. This is the first wave, or this is a wave. I'll show another one, and you know that these circles represents what? These circles represent the direction of propagation of sound waves. Okay? And by the way, the distance between them should be equal, and the distance between the circles represents the distance between the centers of rarefactions or centers of compressions, by the way. So, and another one like this, okay? In this case, let's say that we have person here. This person is hearing the sound. And in this case, let's say that both the person which is hearing, who's hearing the sound and the source of sound, both of them are stationary, are not moving. Let's say that. Yeah, that's it. Then, because of this person, this guy is not moving, and also the car is not moving, the sound waves will move, as you can see, in shape of spheres. It's better to say spheres, and which is represented by these circles. Fine, okay? Now let's say that this, by the way, these circles are or have the same center. So when this moving, when the source is moving, we expect that these circles will start to move. So let's try it. So this one will start to move, and let's say it is approaching near the person. What do you observe? Who can give me observation here?
It will be short.
Raise your hand, please. Yeah.
The sound will increase.
The sound?
Will increase.
The sound. Which property of sound will increase?
The volume. The frequency.
That's right. The frequency. The frequency of sound will increase. That's right. Okay. Who can tell me what? So the person here will hear the voice with higher frequency, right?
Yes.
Now, if so, because the car is moving toward the person. Okay. What will happen if we will move the person or the guy in this side?
The frequency will be less.
The frequency will be less. So he will, that's right, he will hear a voice or a sound for this siren with lower frequency, lower and lower, till the sound vanishes while the car is moving away. What we call this? We call this Doppler effect. By the way, we can, the same result can be if we can go for the same result if, who can say if what? If what?
The result of what?
If the same, there's the change in frequency can be the same if the person is moving while the car is stable. That's it, okay? And by this, we can say that if this person is moving now, so the circle for the wave that reaches his ear will not be the same as the one before it, will not be the same like the one before it. So as you are moving away, imagine that the person here is pulling the waves in his direction. So as the person is moving away from the source, the frequency will start to decrease. That's right, okay? And vice versa, if we are talking about person which is moving, let's say that it's static source of sound, and it's not moving source of sound, and the person is moving toward the source of sound. As he's approaching to the source of sound, he will hear sounds with higher frequency. Now, I can say that we have, I can say that we have now, or we can say now, we have variables here. The first variable is V, which represents what? Sound speed. Sound speed. It will be given in any problem we will solve. Okay, so this one represents sound speed. Okay, and we have Vs, which is speed of sound. The S, which is source.
Sound, yes.
So this is a source of sound. what is the source of sound here in this case?
Car.
The car, that's right. Okay, and V, the receptor or the person who will detect the sound, so we call it VD. So this is the person, if the person himself is moving and so on. So this is what we call V of detector. Okay, and of course we have Fs, which is the frequency of the source itself, and so this is frequency of the source, and Fd also it's a frequency of the person who will receive these waves. We have law that we can apply. We have law that we can apply to find all of these variables. The law is Fd, I mean by Fd, the frequency of the detector, of the frequency of the wave, sound waves the detector will receive, equals Fs, the frequency of the source, V minus Vd over V minus Vs. So, by knowing the variables, you can find the relation between what and what? Between the frequency that you will receive as a person and the frequency of the source of sound. Okay? We will apply now problems to check it out and solve it. And I'll give the example first, then we will solve it together. Okay, back to your seats now, and we will apply now how can we solve it.